Hello everyone, welcome to ROCFT Institute. I'm your friend Gulfam and today we are doing heat of chapter 5 class 7 ICSE. So without wasting any more time, let's just get started. Okay, so tell me, what is heat energy? Or what is basically heat? My answer to that will be heat is the form of energy. In chapter 3 we have already learned that energy has different forms. It can be light, it can be heat, it can be sound, it can be etc. etc. Heat is one of the forms of energy. So I can say heat is a form of energy, but that doesn't give us the complete definition of heat. So heat is a form of energy that gives us the sensation of how hot or cold an object is. I can say that. So what is heat? I can write heat is the form of energy which gives us the sensation of how hot or cold an object is. So whenever I say heat, it doesn't only means something that is hot, but it also means something that is not so hot. It basically means the sensation that you get through touch, through the feel, without even touching it. Sometimes there could be a hot metal right in front of you and you will be feeling really warm in front of that metal. That is heat. Okay? So you cannot just say that something that is hot is referred to as heat, because something that is not that hot or something that is cold basically can also be referred as it has some heat. It might be lower than your body temperature, but definitely it has some heat. It has some kind of energy. If a body does not have any energy at all, then that body will have zero kinetic energy in the molecules. What is heat? How it's formed, or from where do we get heat? So we'll answer many of those questions like that. So basically, heat is the form of energy which gives us the sensation of how hot or cold an object is. Now, you might have heard something that is much more related to heat, something that you know much better, a term that you use in your everyday life. Can you recall what is it? It is temperature. We all know, we all say how hot or cold an object is. So temperature is just that. Temperature is the measurement of how hot or cold an object is. So I can write. So whenever you say heat, there is always a term associated with it, that is temperature. I can write the definition of temperature as it is the measurement. It is the measurement of how hot or cold an object is. So when you are measuring it, when you are measuring the temperature of how hot or how cold that object is in terms of Celsius or Fahrenheit scales, you are using Kelvin scales. Scales could be any, but you are measuring some temperature. So in that time, while taking that into consideration, the definition of temperature is it is the measurement of how hot or cold an object is. You cannot directly say that it is the measurement of heat, because that's a totally different thing. Okay, now we'll also come to that later on. Now, for measuring temperature, we have some scales. Okay, not those scales that you have in your pencil boxes, not those ones. We have some scales. We use degree Celsius to measure temperature, or we use degree Fahrenheit, or we also use Kelvin. The SI unit, I've already said in the physical quantities and measurement chapter. In that video you can watch about what are the SI units, what are units. So right now the SI unit of temperature is Kelvin. So it is internationally accepted. Although these are also used, in India we generally use degree Celsius, in European countries they generally use Fahrenheit, but we all know about it. Now there are some differences between Celsius, Fahrenheit and Kelvin scales. Okay, these are scales to measure temperature. What are those differences? Let us learn about it. Degree Celsius, I am writing in bracket, or let's write the Celsius itself. So Celsius. I don't think I have to say it again. Okay, I always repeat it in every video. You always listen to me saying the same thing over and over again. Take down notes. That will be better for you. Now, Celsius, Fahrenheit. How Celsius and Fahrenheit are interconnected. So in Celsius scale, the freezing point, okay, the freezing point of water is, what is the freezing point of water in degree Celsius? You all know it, 0 degree Celsius. Whereas in Fahrenheit scale, degree Fahrenheit, the freezing point of water is freezing point of water is 32 degree Fahrenheit. Whereas in Kelvin scale, the measurement for freezing point of water is 273.15 Kelvin. 273.15 Kelvin is the freezing point of water. Okay, so now you saw the basic differences, that freezing point of water is 0 degree Celsius in degree Celsius, in freezing point of water in Fahrenheit is 32 degree Fahrenheit, freezing point of water in Kelvin is 273.15 Kelvin. You don't need to remember that 0.15, but still it's fine. Okay, so now there is one common mistake that every student does, and that common mistake is they'll always write degree Kelvin. Babu, this is very wrong. Do not do this. Okay, degree Kelvin, never write it. Okay, because see, you write Fahrenheit and Celsius in degrees, but in the case of Kelvin, you do not write any degree. You just say Kelvin, and that's fine. You don't need to add something extra to what's already been described. Now, not just this, there are differences for the boiling point also. The boiling point of water is 100 degrees Celsius. The boiling point for Fahrenheit is different. The boiling point of water in Kelvin is also different. So boiling point of water in Kelvin will be just 373.15. Just, add 100 to it and you get it. How we are getting it, what are the relation between Fahrenheit, Celsius and Kelvin, we'll also learn that. Okay. Okay, so what are the differences between degree Celsius, degree Fahrenheit and degree Kelvin? So the basic difference is very simple. There is a formula you can use. Degree Celsius, if suppose you are given a temperature in Fahrenheit, suppose you are given 52 degree Fahrenheit and you are told to convert it into degree Celsius. The simplest thing that you can do is you can have this formula: Fahrenheit, degree Fahrenheit minus 32 by 9 into 5. This is the formula. And how to get it in Fahrenheit? Suppose you are given 52 degrees Celsius and you are told to convert Celsius into Fahrenheit. simply just bring Fahrenheit to this side, or keep it in this side, and bring all the other digits over here. So it will be simply degree Celsius plus 32, okay, or sorry, 9 into degree Celsius plus 32 by 5. By 5. So this is for the Fahrenheit. Remember this formula. They are very easy. You don't have to, memorize a long thing. Now, what are their connections with Kelvin? So, suppose if you are given something in degree Fahrenheit and you are told to convert into Kelvin, what I basically do is I take the long route because that's safer, convert Fahrenheit into Celsius first and then convert it into Kelvin. So convert Fahrenheit into Celsius, and you know the formula. You have to convert it with the help of this formula. It's very easy. And then you convert Celsius into Kelvin. The basic relation of Celsius and Kelvin is 0 degree Celsius is equals to 273.15 Kelvin. Keep that in mind. 0 degree Celsius is 273.15 Kelvin. So 52 degrees Celsius will be 52 into 273.15. For now, you can ignore 0.15 and you just write 273 Kelvin. But if you want more precise readings, if you want more accurate readings, more accurate solutions, then you also have to use 0.15. Do not forget that. So these are the relation. Take a screenshot. I'm moving from here. You can take a screenshot of all of these things. Then you can crop it and you can write it in your copy. Whatever you wish. But do not forget this one. Because after this, whatever we're going to learn on the basis of this. So, moving on. Okay. So now we are going to learn about land and sea breezes. But before learning about land and sea breezes in detail, let me tell you one thing. Suppose this is the plot of land. Okay, you are living in this place and your friend is living in B. There are two different towns or cities, whatever you say. You are living in A, your friend is living in B. Your name is suppose Raj and your friend's name is Rahul. Okay, so Raj and Rahul, they both live in different places. Now suppose Rahul experiences a very hot climate. Okay, the sun's rays are very direct on it. So Rahul experiences a very hot climate all over the year, whereas Raj experiences a moderate climate, not so hot or not so cold. So it's generally covered with clouds. There's sometimes sun rays, sometimes you don't have sun rays. It's normal. So definitely the air all over it, all of the air will be cold compared to this one. Not very cold, but cold compared to where Rahul lives. The air will be warm. So you can do an experiment. Warm air always rises, and you can do an experiment to show it. We are going to learn about that experiment very soon, but right now keep that in mind that warm air rises. Rises where? In the heaven? Nah, the rises up in the atmosphere. Cold air, on the other hand, do not rise. It settles down. You can say it condenses, it comes down, settles down, whatever language suits better. Warm air will always rise up. It will always go up. Warm air. But cold air, on the other hand, it won't go up. So what happens basically is, the cold air, when the warm air rises up, what happens? The air has gone up. So now there is space down over here. in this region you are getting a little bit of space, so the cold air will rush to this space. Okay, so the cold air will rush to cover this space, and this is what we call wind. Understood? So I think now you have got some of the idea now what we are going to talk about land and sea breezes. But before to that, we are also going to discuss something more. Okay, so that is water. Very special. Why very special? Why I'm saying water is so special? One thing keep in mind. Whenever you heat water, okay, and you heat warm up a food item, or suppose, let me give you an example. Take a spoon, take 1 glass of water, heat the spoon, heat the water will get warm, it will start boiling. Remove the spoon, remove the water, keep the water and the spoon at room temperature without switching on your fan, anything, keep them at one place. After 5 or 10 minutes, you will find the spoon has come down to normal temperature. It's not hot at all, but the water is still hot. This is called specific heat capacity. Excuse me, specific heat capacity. The specific heat capacity of water is very high. What do I mean by that? I mean that water simply takes a lot of time to get warm or to get hot, or to increase the temperature of water you need to provide more energy, or you will need more time. But also on the other hand, to cool down water you will need to take out more energy, or on the other hand I can say you will need more time. So water restrains or contains heat a lot better than any other substance, and that is because of the molecular structure of water. Now you will learn about that in higher classes. Here what you are going to learn is that water has higher specific heat capacity compared to other metals or non-metals. It has a really good and high heat capacity, and water is found almost everywhere. There are many other substances which are better at heat capacity, specific heat capacity, than water, but they are not readily available. But water is available. Therefore, you find, let me give an example, one more example. When someone is driving a car, and suppose if the engine gets really hot and the car suddenly stops, what do? You put some water in that. There is a tunnel, or there's a funnel in some cars, in some old cars. You put some water in there, and the water helps in cooling down obviously the carburetor or the car engine, and then you can go start the car again and go to your destination. But then one more example that I can give you is, whenever you get burned, what do you do first? If you have ice, you put ice on that burning place. Or what you do is you just go rush for cold water if you don't get ice. Now the reason why you do it is because of the high specific heat capacity of water. That's the only reason. Now water has a high heat capacity. Got that? So it takes more time for heating and also more time for cooling. So both for heating and cooling you need more time. Got it? Write it down. Now we are going to learn about land and sea breeze. Okay? So what is land and sea breeze? You will find this land and sea breeze thing generally near beaches. Okay? Not in every place. You'll find these land and sea breezes generally near beaches. I'm sorry if the sun looks like someone's face, but that's what the sun is. So this is sun, okay, this is the land, and this is sea, okay. Label it down, sea, land. Now, because during daytime, okay, during daytime, because water has high heat capacity, it takes longer time for water to get heated up, okay. So it takes longer time for water to get heated up. So the place, this air above the water is still cold, or I could say comparably cold to land, whereas in land the air above the land is comparably hot. Now, I said it earlier, hot air will always rise up. Hot air will always rise up. And you see, that's where the thing comes. Hot air will rise up. So, the cold air will have to take the place of the remaining portion. And this is the thing that you find near beaches, beaches near Goa, in Mumbai, or in Visakhapatnam, or in many other coastal areas of India. You will find this phenomena happening. So we call it that, we say that really nice cold wind is blowing even during the day. But this is what's actually happening. Yes, definitely the cold air is blowing, but this is what happens. The cold air rushes towards the land when the hot air of the land rises up. The same thing happens, but in opposite manner. Now during night time, this one is known as sea breeze, okay, the one that you learned right now, what had happened during daytime. Sea breeze, I forgot to write in that diagram. So sea breeze, that happens during daytime. The flowing of cold air towards the land during daytime is known as sea breeze, whereas just the opposite happens during night. Okay, let me show you. So this is the same land, okay, the same land, the same sea. Now throughout the whole day, this is the night time, okay, night. Throughout the whole day, the water was getting heated up. So basically, after a little bit of time, the water will eventually get hot, and the hot, warm water vapor will rise up, resulting in the air in this area also becoming hot, and this air will also rise up. Okay, so hot air, warm air will rise up. Warm air will rise up. But because land or solid objects, land is solid, so land, because it's solid, it has low heat capacity. Therefore, it won't retain heat. So it won't retain heat longer. Soon when the daytime is gone, when night starts coming up, the land will start cooling down and the cold air will start settling. Now this cold air has to move somewhere. Now because warm air is going up in the ocean, in the sea, this portion we are not having any air at all. So there has to be someone or some air to go and cover up this place. So the cold air of the land will rush toward the ocean areas, and this is what we call land breeze. You can literally see this phenomena, both of these phenomena, the land breeze and the sea breeze, near the beaches. Okay, in coastal areas or in any coastal areas of the whole world, you will find these land and sea breezes happening right in front of you, and transfer of heat. How heat gets transferred from one body to excuse me, from one body to another. You might have seen during the winter season, now winter season is going on, so what do? To warm up your hands, you put your hands in front of the fire and your hands are getting warmed up. But are you actually touching the fire? You're not touching the fire. Then why your hands are getting warmed up? Now this is what I say, or what is said, is known as induction. Induction does requires a medium. Over here the medium is air. Through that fireplace, the air is carrying the heat towards your hand, and then your hand is getting warm, and through this you are suffering, and with the help of this you are fighting cold. But let's not focus on that and focus on the transfer of heat. So suppose my diagram of fire is not that great. So suppose this is, I don't know, this, does this look like fire? Okay, this is fire. Don't laugh at me, please. This is fire, and this is your hand. Very pretty hand. Doesn't look like at all. Looks like bushes. Doesn't matter. Okay, let's not do this. They do not look like hand at all. Whatever it is, suppose there is an object. We are physics students, chemistry students, math students. We draw like this. So suppose there is an object. Suppose the object name is A, and this is fire. There are air molecules in between the object and the fire. What happens is, the air molecules in front of the fire, they are actually absorbing the heat, so they start vibrating more. Means hot, something that gets hot starts vibrating more. The molecule starts vibrating. Suppose if you heat water, the water will start boiling or vibrating more because you are heating it. So the same thing happens with the air molecules. The molecules in the air starts vibrating more rapidly, and the molecules in front of them also starts vibrating. By this process of vibrating, the heat energy gets transferred or induced from this place to this object. And in case of the object, you're putting your hand, you yourself are there, whatever. This is how room heaters work. Okay, so this is what is basically happening. Transfer of heat. We call this process induction. So if someone asks what is induction, induction is the process through which heat energy is transferred. On this chapter, okay, it's the process through which heat energy is transferred from one body to another body by or with the help of some kind of medium. Here the medium is air. What is a medium? Medium is an object or something through which the energy passes. Okay, so air over here is the medium. Suppose you are taking a beaker. There is water in the beaker, and you are heating up the water with the help of a Bunsen burner. Bunsen. So you are heating it with the help of a Bunsen burner. Okay, the water, and then you are putting a thermometer. Doesn't even look like a therm. Please, just, it doesn't look like a thermometer at all. Please spare me. I ask for forgiveness for this very weird and worst diagram in the whole world. But please, I'm really sorry. But this is the thermometer. Okay. Excuse me. And this is the Bunsen burner. When you're heating the water is getting warm. Okay, it's getting heated up, and then that heat is transferred from the Bunsen burner to the water and then the thermometer, and the thermometer shows you a reading of suppose 70 degrees Celsius, whatever. Okay, so this is what is happening. now the reading won't be constant, it will be rising up definitely. So okay, so there are really good experiments. We have covered up all of the discussions in this chapter, and let's discuss two of those experiments that are really important in this chapter. An experiment to show that air expands on heating. Okay, let me tell you one more thing. In this chapter, this is a chapter basically focused for ICSE students class 7. Okay, if you want to know more in detail about heat, what is heat, how heat occurs, what are the things that happens to molecules when you heat an object, or what are the basic fundamental ideas or philosophies of heat, then do comment down below. Tell me you want to know more about it, and I will definitely, if I get a lot of comments, I'll definitely make a specific video explaining you just what is heat, and that will be really fun. So now let's focus on show that air expands on heating. The basic experiment is very simple. Take a bottle, okay, steel bottle or whatever bottle you like, okay. On the cap of the bottle, on the mouth of the bottle, you put a balloon. Okay. Now take the same balloon. When you heat the water, I have drawn very close to it. Okay, let's draw it again. I don't like these drawings. So let's take the bottle. Let's take the bottle again. I'm sorry for the delay, but I cannot do anything. I want to draw as good the diagram as can be. Now this one looks good. Now take a balloon and fit that balloon on the top of a bottle, on the mouth of the bottle. Okay, so at first the balloon would be looking like this. That's normal. Okay, now start heating the bottle. Okay, provide some heat with the help of some Bunsen burner, lighter, whatever you have. You will see the balloon is started expanding. The balloon has started expanding. Now this shows clearly that air expands because there is nothing inside of it. You have not put any water. There is no chemical substances inside of it. There's only air. So when you heat the water bottle, the air inside the water bottle gets heated up, and because the air is getting heated up, definitely the air is expanding because you don't see the bottle expanding, you see the air expanding, and because of the expansion of the air, the balloon is also expanding. So this is the experiment to show the expansion of air. There is another experiment that shows the expansion of water. Here is the experiment. You can see it right on the screen. This experiment is very similar to the one that I have just taught. The only difference is you put a straw and you heat the water. The same results you will find. The water level on the other one will rise up, proving that water also expands on heating. And not just air and water. Any object, any metal, non-metal, whatever you take it, will expand on heating. Okay. So I guess I've covered everything that is there. If you have any query, if you have any question, if you have any doubt, do not shy to comment down below. And all of the links for notes, descriptions, question answers, PDFs, links, whatever you want. If you want to know which camera I'm using, if you want to know which board I'm using, if you want to know which pens I'm using, if you want to know whatever that I'm using, I mean for study material, then go to the link description down below. Everything is given down, everything is listed below. You can just go and watch it if you want them. And not just that, thank you so much for so much of love, so much support. I've been making videos for a long time. I've been making videos for like for like 6 or 5 or 6 months, and I've been getting really good love. And one more thing that I would like to say to my dear students, please do not give your WhatsApp number in the comments. Please don't. Because see, I won't be using that WhatsApp number. I won't be taking that WhatsApp number and calling you. But other people on YouTube might, do some wrong things with that WhatsApp number of yours. They might call you, they might disturb you, and I don't want that. And please do not ask for my number. I cannot provide you my number. If you want to, have a much more deeper conversation with me, you can follow me on my Instagram. My Instagram ID will be given in the link description down below. You can follow me over there. You can follow me on my Facebook page. The ROCFT Institute is on Facebook. You can follow us there. You do not need to take my number to learn better. Just follow me on those websites, and whatever your question you have, the best thing, you can follow me and you can subscribe this YouTube channel. You can watch the videos, and if you have any doubt, you can comment down below. Nothing is better than this. You're learning for free. And that is what I'm saying. Do not, open up your privacy. Just don't do that. Okay? Giving out your number to anyone is not a good idea. You don't know me. I don't know you. So how can you rely on me that I will take your number and not share it with someone else? Do not do that. You have done this with me. Do not do it anyone else. Okay? I have already deleted those comments. I don't want to see anyone commenting their phone numbers, their WhatsApp numbers, whatever numbers they're providing. And I don't want anyone to ask for my number. If you want to ask something, ask me questions, and I will be really happy to answer those questions. Okay? Thank you so much for all the support and all the love. I know you are very curious. I know you want me to answer all of your queries, but guys, you have your privacy. I have my privacy too. So don't do that. Thank you so much for watching this video. If you like this video, give it a like and subscribe to the channel. That helps us grow a lot. And do not forget to support us on Patreon, because we are not earning anything from YouTube. This is all your support, and if you pay us on Patreon, that is whatever the income that we have got. So thank you so much for watching the video. See you in the next video. Bye-bye.